Okay, so what do we need to talk about next? Well, let's talk about the pieces that make automation possible within industrial and other environments. And it's about sensors and actuators. But I want to talk about them a little more generically first and just talk about measurement instruments. So the old term, going back many, many decades, is measurement instrument rather than the concept of sensor. And a measurement instrument, in the traditional term, over here labeled 0 on the left, is simply that we have some kind of a thing that is a sensor, and then there's a gauge that shows what the sensor is reading. And these traditional measurement instruments were typically very analog, and you simply had to walk up to them and look at them. And that's how you read it. Then the next step was to say, well, let's take that sensor and let's put its data through an amplifier and a conditioner and give us a display. So the amplifier and conditioner introduced a digital component, giving us greater granularity, greater accuracy in the actual measurement. But still, we generally went up to the display to look at it, whatever the display was. The next phase, labeled 2, and these aren't necessarily sequential phases, there's some overlap, but it gives you an idea of the process that we've gone through. We have the sensor that goes to the amplifier and conditioner and still has the display, but someone had the great idea, well, why don't we keep a history of what the display has read in the past? So at any time, an engineer can walk up and view the display recorder and actually see the trends that have been happening, still requiring going to different locations to look at the information in most cases. And then the final stage of automation is, okay, let's take all of that stuff and let's pass that data to a control center of some sort. And at that control center, we can then view all of the information from these measurement instruments that we today call sensors. Now, of course, this is focusing on just measuring or monitoring, but actuators can also be used in the same concept, meaning that now that we have the ability to process what is coming in from the sensors, we can also instantiate an actuator to tell it to change something, change flow, change temperature, turn something on, turn something off, etc., right? And so these concepts of sensors and actuators play a big role in IoT and in traditional industrial automation. So the sensor reads the information, monitors the information. The actuator can be told to take action in relation to what is being read. This is true with IoT, and it is also true with traditional industrial automation. Here's some examples of sensors. I'm not going to spend a tremendous amount of time on it, but it just gives you an idea. These all happen to be wireless sensors in this case. And we see a strain gauge sensor. So this is something, you see that flat portion, it might be mounted on a wall or on a column, and it detects the slightest bend or bow in that wall or column, which can tell you the strain that it's under. These are used in order to monitor the health of a building, a bridge, things of this sort. Strain gauge sensors are very commonly used in that way. So you might have these in all of the columns of a bridge, sending their information back to some monitoring station that can tell you if there's any excess strain based on environmental conditions changing, the age of the bridge, so forth. We have an ambient light sensor, and so this can just detect light, and based on that, then you might have an actuator that is fired. So the light sensor tells you it has detected light, and then you can send a signal to an actuator to take some action based on that detected light. And it might be a different action depending on the time of day. Here's a simple all-in-one unit from Edimax, which is an air quality sensor. So, looking at things like carbon monoxide and things of that sort, and then reporting back to the cloud in this case, and you can have automatic alerts fired from it. We have a range sensor, so it can not only detect that there's something at a location, but how far away is it? Is it getting closer? Is it getting farther away? And decisions can be made based on that. And in the lower right, we have a sensor from Lord Technologies, which is actually a sensor connector node. So you can take any traditional sensor that can be wired to the appropriate plug type that you see here, and then this device will wirelessly send back that sensor data to the network so that it can be processed and possible actions can be taken. And then we simply have a table of different temperature sensor types, thermocouples, RTDs, thermistors, infrared, the common ranges and so forth that they have. The goal is not to go in depth into all of these sensors here, but just give you an idea of some of the very common types of sensors that are readily available. These happen to be what we would categorize as IoT sensors. They use wireless communication protocols, some of them proprietary, some of them standards-based, in order to transmit information back to the network that can be used for processing. So that gives you an idea of sensors and actuators, which are really the starting point of the data that's used in industrial automation.